Yes, any issue with this paper?
There is no issue, but one doubt is there.
Yeah, yeah, sure.
There was to represent minus 13 in 10 in a 8 bit. So
Mhm.
just we need to do only two. I mean, if you want to store, I mean, 8 bit means only we need to do uh, padding only, no one padding only, no, because it is
Yeah, yeah,
occupy
yeah.
only in a 5
Yeah.
bit.
Yes, yes, yes,
Okay,
yes.
okay. Thank you, sir.
For minus 13, you have to use the 5 bits and 3 bits that is used as a padding. Any other doubts? No. So, shall we move to week 6 content?
Sir, is the deadline of the six content postponed, or is it the same as Wednesday?
Same, same, same.
Sir, can because most of us we were preparing for quiz, we did not watch much videos of week six. Can we have it postponed to like
So
Saturday?
you can do that. One thing is that you can write a mail to the support team because this
Actually,
particular thing will be handled by the support team.
Okay, sir.
actually,
Okay.
we have requested this from Aniruddhan sir. He said he
Hmm.
will talk to professors and all, but till now we didn't got any update. So for that, I guess.
Anirudhan sir.
Yeah,
Actually, we had a meeting arranged
Okay,
like
okay, Anirudh sir. Yeah.
yeah,
Okay.
yes, sir, and that sir was talking about live sessions and all that, and he
Hmm.
asked any suggestions, and we said this that postpone
Okay.
the submission date. He said he will do it, but till now we haven't seen any changes.
he said he will ask to the professors if this can be done, and if this can be done, then they will do it.
You can do one thing is that you can directly mail to the support team also.
Okay, okay,
Okay.
yeah.
You talk with the professor, that is okay, but directly mail a support team also. Okay, and I will communicate your message to the support team also on behalf of you. Uh, Now we go with the week 6 part. Hmm. So basically in week 6.
Hello,
Okay.
sir.
Yes, yes.
Yes, sir. I was having doubt in like solving the problem of a minimum number of gates. Uh, there
Okay.
was a there was two problems in this quiz one, so I
Yeah.
was confused at how to solve it.
Okay.
Can you
So, just can you tell me?
actually? It was A bar, B, C bar, and we have to use the universal to input universal gate. So
Universal is either NAND or NOR. Okay.
yes, sir.
So if we see that A bar C bar, so can I write A plus C bar dot B? Okay. And if I take a double implement of this one, so when I use the A and C XOR this particularly, sorry, apply the NOR gate, so it is A plus C bar. Okay. Now with the B, I am using a NAND gate, so it is A plus C bar dot B whole bar. Again, one more NAND gate, one more inverter. So I'm using the one more NAND gate. So it is a plus C bar dot B whole double whole. Yes, now it's fine.
Yes, sir. So, is there any particular technique to solve it, or is
The better technique is that the first thing is that if in week 6, I think active low particularly thing will be discussed. So better is that either you can use at a, like for example, A plus C bar and B bar B. So we apply that A plus C bar. Okay. Now we have to implement with the B. Okay. So A plus C bar B. So it is a plus C bar, and here is the we are getting the A plus C bar dot B. This is the option. This is the correct option. A plus C bar dot B. Okay. Now this is the NOR gate is okay because it is A plus C bar. It is a AND gate, but we have to implement using the NOR or NAND gate. So what should I do? If I convert this one, okay, so I have to use one more inverter. Why? Because I am using one inverter, and so I have to implement or basically eliminate the effect of that inverter inverting. We are using the one more inverter. Okay, so the way is that you can implement with the help of AND and OR and convert them into the NAND and NOR. This is the only way. If you do practicing on that one, I think after sometimes after practicing you will identify that how many gates will be. Like for example, I just say that mm, AC plus BC is given. I have to implement using the NAND universal gate. Okay, the first approach is that if I see the AC plus BC, so I can apply AC ending and BC ending. Okay, and use the OR gate. Okay, so we implement the AC plus BC. It is fine.
yes, sir?
Okay, now we have to implement using the universal gate. So what should I do? If I use one bubble here and I use one bubble here, so two times inverter, two bubbles, that means two time inverting, and two time inverting we are getting the same, so there is
Yeah,
no
sir.
change.
Yes.
Now second is if I use one inverter here and one bubble here and one bubble here, two bubbles cancel out the effect, so the output will be same. Now this become a NAND gate, this become a NAND gate, and this become a NAND gate. The first thing what we do, we implement with the AND and OR gate, then after that we convert into the NAND and OR gate. This is the only approach, better approach.
Okay, sir. And sir, problem
Mhm.
which I asked, if we implement by the normal only, by means doing uh, NAND operation only, or
Mhm.
the AND gates only,
Excuse me, sir.
we can do that.
With the NAND only. You are asking about the NAND only, na?
Yes, sir.
So what you have to do that A plus C, this is the ORing operation and invert of this one. Okay, for the ORing operation you require three NAND gates. Okay, then invert this one is a one NAND gate, four, and implement this particularly part you are required two more gates. Total of six gate is required. This is
Means
two.
for ORing, we need 3 NAND gates.
Yeah, for the ORing part, you will require the 3 NAND gates.
Can
Okay,
you
if
show it
you,
to us, sir?
can I draw?
Yes, sir, because I'm not
Okay,
getting it.
okay. So basically, what is the you require a bar, C bar, to A, C, so becomes the A bar, C bar. Now, if I use one more, that is A bar dot C bar whole one. So that is A plus C. Okay, so basically, this one is whole. This one is
Yeah,
all.
sir. Got it, sir.
Yes, anyone asking something?
Hello.
Yeah.
Yeah, for the yesterday's quiz, there is one question there.
Mm-hmm.
How many gates need to be needed to implement that logic there? But in the option there, something get given 10 AB, something like that. I think one question. I don't know
Can
exactly which one.
you have okay? You remember that? Not you do not.
No, it's someone question is something there. I think number of gate asked there should be numbers are there, digital numbers there, but the options are provided like that 10 AB like that. I think I don't know exactly which question there. And one more
One.
thing, basically observed there, the number of I think I don't know the most of the students have paid yesterday exam there,
Mm,
but the number of questions the paper was a little too much lengthy there. So I think around 29 questions are there. I
20
don't know
questions. Yeah.
20 29.
Okay.
So earlier exams you have observed there now paper something around 18 19 questions are there. And this time I don't know 29 questions are there. Other students have their opinion there, but my personal observation there. So it's take too much time there.
I have similar doubts, sir. That the question he asked about that 0, 1 and AB option, I didn't get that, sir.
Wait a minute. Can I
If you
check
have a
it?
question paper, sir, then you can solve it now.
Wait a minute. Wait a minute. I just check which question you are asking.
Basically, from as compared to previous times, we have many sub parts of the question, so it is very much easy for us to solve. But for this quiz, which happened yesterday, we got too much questions.
Yeah, too much
Yeah,
questions, too much
independent
lengthy,
questions.
and it
So
takes
yeah,
too much time for this all. Others didn't get it. I
but
think
then also paper was fine. But yeah, this is the
10,
observation.
11, 12, 13, 14, 15, 16, 17. Yeah. 18, 19. Okay. So you are saying that. Okay. So the paper length is.
yeah, too much. If you any expert is get to solve it, I think he'll not be able to solve it. In very high expert person can solve it, but in general, commonly it takes too much time there.
Okay.
29 questions, and earlier 3 terms questions I have gone through it there. So max 18 questions are there max.
Okay. Okay. Actually, yeah, you are also asking the minimum number of logic gate required to implement at PT3 if only two input AND OR and NOT gate is available. So 0, 1, B and A is the option.
It should be numbers there only.
Yeah. B and A is maybe the incorrect options. Okay,
That is the
B and
first
A is the
observation. Other I don't know. Need
yeah, but
to
if we say that 0 and 1, so the answer should be in between 0 and 1.
so more than that,
More
what will
option.
be the
Yeah, no particularly. From 0 and 1? it will be the implemented. Okay. Yeah, B and A option is
Can you solve
incorrect
it,
from
sir?
that. Okay. Yeah, yes, to check my screen is visible. Yes, my screen is visible. Hello.
Yes, sir.
Yeah. So at this point, what is the output? This point, the output is AB. Okay. At this point, what is the output? That is the A and C. So A plus C. Okay. What is the output at this point? At PT1, if I am talking at PT1, it is a AB dot A plus C bar. Okay. So it becomes a AB plus ABC whole bar. And if I solve it, so it becomes the AB bar. Okay. Now from PT1 AB bar, it will be go to the PT2. So the at PT2, what is the output? It is the AB bar is the one signal that is going from this way, and second is a C. AB bar plus C whole bar. So it becomes a B double bar dot C bar. So it becomes a B C bar. Okay, so at PT2 we are getting the ABC bar. Now this is go to this way. So PT3. One signal will be with the PT1, so it is a AB. One signal from here PT4, so I have to calculate the PT4. So PT4 is what? A plus C from here, and that A is from here. So A plus C multiply by A and bar of this one. So if I multiply, so it plus A plus AC, that becomes the A bar. So PT4 is A bar. Okay. Now this AB and this A bar, so it becomes a AB bar from here and A bar from here. So again we are taking the invert of these two. So AB dot A. So it becomes a AB. Okay. So PT3 we are getting a AB. Now PT5, in the PT5 we are getting the PT2. So one is the A, B, C bar, and second X or AB. Okay. So can we solve it? Now the question is that for the PT3, how many gate is required? So we are required only one AND gate, and that is AP. Okay.
Sir, in PT1, how you did AB dot A plus C bar to AB plus ABC bar?
if I multiply it, so AB multiplied by A is AB, and AB multiplied with C is the
Okay, okay,
ABC
sir.
bar.
Okay.
ABC. Any other doubts? Wait a minute, hold for me.
Hello, sir.
Hello. Yes.
Sir, there is a question in quiz of week 1.
Hmm.
If V out is equal to
Quiz of week one.
E power
Quiz. Okay. Quiz one or week one?
quiz 1,
Okay.
V out is equal to E to the power something.
Yeah, that is already a part of the assignment one.
Yeah,
The
please discuss that once.
assignment one solution is already available in the particular folder now. So if you go with the particularly contained part, like for example, if it is a expression, okay, we have already discussed that. So this is the curve. Okay, so what we have to do, we have to calculate the VIH, VOH. Okay, so what we have to do, we have to take a differentiation. If any expression is given,
Sir, I am differentiating, but I didn't get the proper answer, so I want to discuss it.
okay, so you have to given the V out, where the V out is the output and V in is the input of the inverter. The supply voltage VDD is 1.5 volt. What are the values of the following parameters? So yeah, how you solve that one? Now can
I
you tell
take the
me?
differentiation with V input.
Okay, so you are taking the V out, dV out upon dV in.
Yes.
Okay, so what is the differentiation part?
Minus VDD upon
Minus VDD upon
1 plus
1 plus e
E
raised to power 25 P in minus 15.08 VDD upon VDD
VDD is whole square total.
whole square. Okay,
Multiply by
yeah,
E to power 25 in V in minus 15 point.
this one.
Into uh, yes, into
Hmm.
25
Into 25
V in upon VDD.
V in upon VD.
Yes.
Okay, so how you basically take the differentiation of this one?
Sir, that is e to the power 26 V, sir. we written down e to the power 25 v,
Yeah.
that is e to the power 26.
26. Okay. So basically, I just want to ask that how you differentiate this one.
So using chain rule.
Using chain rule. Okay. So if I am taking 1 upon x, okay, so what is the differentiation of this one? Minus 1 upon x square into dx, if I am respecting with the respect to t. So dx upon dt. Yeah, you are using the same method.
Yes, sir.
Okay. So minus vdd upon you have taken this one, and if you differentiate this particularly component, lower component, so minus differentiation of minus will be 0. Okay, and now the differentiation of e raised to power x is e raised to power x. Multiply again this particularly no term will be the differentiator. So this is the, if I differentiate this particularly term, so it's remaining the minus 15.08. Sorry, it is at 26. Yeah. Okay. Now put the value of v in, and put this value will be equal to the minus 1.
Yes, sir. I put it with -1.
Okay. So first of all, VDD will be cancelled out with VDD. So it becomes a minus 26 V in e raised to power 26 V in minus 15.08 VDD upon VDD multiplied with 1 plus e raised to power 26 V in minus 15.08 VDD upon VDD and whole square of this term. Okay, so when you put a 1.5, so what is the value? Can you calculate what is the value of this one?
Sir, I have substituted e to the power whole with x, and I get a quadratic equation, and after finding the during finding the quadratic equation, I get a complex number. Then I drop the question.
Complex numbers.
Yeah, root under
Mm,
-3 something.
okay. So we can do one thing is that we can provide a solution for this one. Okay. The method is okay. Okay. Maybe you are getting some mistake. Okay.
Okay. Okay, sir.
So we will provide the solution for that.
Okay.
I solved the sum by your method only. That
Mm-hmm.
assume that the term which is the power of the e as the
Mm-hmm.
x, putting the value of VDD. and then apply that formula is dv out upon dv is equal to -1.
Yeah.
And I have done, but answer was different. The answer for VI line was I got something 0.79 something, and for VIH I got something 0.9 something that.
I got correct one, sir. I got 0.688 and 1.0533.
So maybe the basically the calculation error is there because we have already solved this one. So the answer will be the
Actually, I've done the approximation. Is
oh,
is that about means doing approximation?
but I don't think so. If we are using the approximation, so that much variation will be there. Okay, we are already provide the range in a way that if you are using the approximation method, your answer will be in the range.
Sir,
Maybe
here
some
that
particular.
that you applied the chain rule, sir. But here we have to apply U by V rule because uh, in numerator we have the 5 and in denominator that 1 plus C equation.
Yeah,
Then
in the numerator that is the VDD. VDD is constant. So how we apply the U by V rule?
that U part get 0 and that V part after
So again,
differentiating V
again,
part
again, again, we are getting the same thing. No? Again, we are getting the same thing. If you apply the U by V part, again, we are getting the same thing. If U is your constant, so we are getting again a same value. Okay. Like for example, if I have a x is equal to cos of 2xt. So what is the differentiation of this one? Yes, what is the differentiation of this one?
T into sine 2xt.
Okay, if I differentiate with respect to the x, with respect to t, so what is the answer? Minus sine 2xt. And if I differentiate this one with respect to t, so it become a 2x. Okay, so either you apply the chain rule or either you apply the any other rule, every differentiation will be same. The similarly thing is that if I with respect to t we are differentiating.
Oh,
Okay, so similarly thing if you apply the chain rule or if you apply the u by v rule, the answer will be same. But the thing is that if we have multiple parameters that is dependent on the differentiation term, so you have to basically apply the chain rule for v part also. Okay. Hello.
Hello.
Yeah.
Yeah, I had just different observation for this question there. VCT
Yeah.
questions and that way and all that. This question carries only 1 mark there. Okay, but there are two questions for the VA and VS there. But the effort, amount of time and efforts we need to put it to solve that derivation and all that, and the time and all that, and this carries only 1 mark, single mark there. I literally,
Okay.
as the paper is lengthy there, na, already 29 questions, and this question carries only single mark. I literally left these questions, two questions, because
Okay.
this, yeah. So this is my observation. Other
Okay.
people, I
So
don't know.
basically the thing is the paper is lengthy. So
Yeah,
we will we will do that. We will try to
because
do that in
and
the
this particular these questions it takes time there, na? Okay, to
yeah
solve
yeah
it.
yeah
Okay, yeah, and
yeah
this carries
exactly.
only single marks. When I go through the question sets and I see that's only single marks there, I kept it for the last one there, and literally get time out of and literally left these questions because it carries 1 mark and taking off amount of time to solve it, and so I
Yeah.
switch over to other questions.
Okay.
Literally.
Okay. Okay.
So please, this is a suggestion observation my there. So the
Yeah.
amount of
So we will
questions
do
and
that.
the amount of efforts time needed to solve that questions and the out of the marks carried and the total questions and all that to be just consider next time there. Hope so.
Yeah.
Okay, thank you.
Okay. Any other doubt related to this one you can ask. Yeah. We understand that paper is lengthy. Okay. So we will do one thing is that in the quiz part we will basically. But
For the
actually, thing is that like for example, this is your feedback. But in the previous term, I think the paper length should be same similarly somehow. So they are not complaining. So that's why we are thinking that you will complete it in less than 1 hour. So the thing is that one. But in the quiz two, we will consider this thing.
Yeah, most
Okay.
of the other subjects, maths and all that,
Mm-hmm.
the what are the questions, lengthy questions and all that, they're putting in the grading and practice assignment there because this takes
Mm-hmm.
most of the time. But in actual exam, they're giving the harder questions will be okay. That tricky questions or that one question needed that 2 3 logics and 2 3
Mm-hmm.
different scenarios and need to acquire and solve that question there that
Okay.
but that they are taking not much that much of time and but for the grading assignment you can have 1 week's time there to get into the depths and solve it
Yeah.
thoroughly and all that and getting understanding it there because most of the
Yes.
practice
Yes. Yes.
questions you
Yes.
can
Yes.
see there is a very hard there as compared to the
Yes.
grading some questions and other subjects also there
Mm-hmm.
for the electronics or
Mm-hmm.
ESTC or C programming or maths
Mm-hmm.
and all that. Practice questions are
Mm-hmm.
harder as compared to the grading but that is for
Okay.
the understanding is okay but actually the when you have 1 hour time period there and then
Mm,
it's all that it need to be taken care.
okay.
Okay, thanks. And to get to the depth of this gates and all that and this we need to practice it more na? What's your suggestion there?
Mm-hmm. Yeah, yeah. For the gate part, you have to practice it more.
Most of the part but most of the whole subject there need to the solve
Mm-hmm.
maximum questions and more practice and all that it's there.
Mm-hmm. Exactly, exactly.
Okay, thank you. We'll make it.
Can you
Mm.
provide more questions on this? Or maybe,
For the basically number of gates.
yes, sir. And of course for the VTC also.
Okay, for the VTC also and for the number of gates. Okay. Uh,
Sir, I sent you one question that in GSP that number of gate problems, sir.
where G space.
Yes, sir.
Mm,
Sir, I personally texted you, sir.
okay, 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 okay.
That one, sir. This one in that one, sir. That Rituraj.
Okay, so
That one, sir. This last one, sir. Direct message in last one. That
In the section of direct message, last one.
Ritu.
yes, sir. Yes, sir.
Mm,
So that one problem, sir. From
okay,
POS method,
implement.
sir. When I solve it from POS method, I got
Mhm.
that answer. But when I solve it from SOP method, I get more number of get. And Prabhu sir also
Mm,
told that. But I
yeah.
didn't get the how number of get increased by changing their method.
Basically, if we like, for example, I am already saying that like uh, if I have a SOP term, okay, so better that you can simplify with the NAND gate.
Yes, sir.
Okay. Similarly, if I get the POS term and you try to that one with the NAND gate, so the number of implementation is different. Number of gates is different.
Sir, I solved it POS from POS term and the question asking about NAND gate, I get the
Yeah.
correct answer. But
Yeah.
when I solve it from SOP term, I get wrong answer.
And using the NAND gate or NOR gate?
NAND gate, sir. The problem asked about NAND gate, NAND
Okay.
2 gate and
So
NAND 3 gate.
yeah. So if we are using the for the both SOP and POS using the NAND gate, the answer is different. The number of gate is different. Okay.
Also, because
Because
the equation is same, sir.
yeah,
Both the POS term
equation
and
is
SOP.
same. Equation is same. Like for example, we have a one term is A, B, C. Okay. Now
Yes, sir.
in the SOP term it is ABC. Now in the POS term it is A bar plus B bar plus C bar.
Yes, sir.
Okay. If I implement ABC with the NAND gate, so AB bar. If I take a one more C, okay. So A B. We are using the two input now.
Yes, sir.
Okay. So I just invert that one. So it is a AB bar, then AB, then we are using the C. So it is a B, C bar, and again if I use the inverter, so it is a B, C. Okay.
Yes, sir.
Now if we implement the A bar, B bar, C bar. So first, what we have to do? First we have to use the A bar, B bar, okay, C bar. Now we are implementing, or we can do the ORing, okay, and use the input A, so it becomes A bar, B becomes B bar, so it becomes the A bar plus B bar. Okay. Now if we are going to implement with the C also, so the number of gate is changed. Number of gate is changed.
Yes, sir. From POS term, I got 3 gate, and from SOP term, I get 4 gate.
Yeah. Okay. So thing is that if we implement the SOP term, better is that we can use the NAND. If the POS term we are implementing that one, we are getting the basically NOR gate is better. Okay, if you are talking about the NAND, if we are talking about the minimum gate, so you can implement the POS using NOR gate, then your number of gate is equal.
Sir, but that problem, sir, they asked about
Yeah,
NAND
NAND gate.
gate and
Yeah,
AND gate
yeah.
and
So
3
in
gate.
the if you are not changing the, I am just telling you that if you are using the SOP term using the NAND gate and POS term using the NOR gate, the gate is equal. But if we are maintaining the same gate, like if we are saying that this gate is also NAND gate, okay, we see that the SOP and POS both are equal.
Yes, sir.
Okay, but the number of gate will be changed. Number of gate will not equal because the implementation.
Yes, sir, in that problem, sir, they are asking about NAND gate. That's why I tried to
Yeah,
implement it through
yeah.
SOP term.
No, I
But
just tell that I just okay, that is okay. But the thing is that if POS better is NOR gate, and if they are asking in the question that you have to implement with the NAND gate, so the number of gates should be always different. We can't say the same number of gate will be used. Okay.
okay, sir, I got that. I got this
Yeah.
concept.
Any other doubts? Yes, any other doubts? No doubts?
Sir,
Any
there is
feedback?
your question of simplification.
Mm-hmm.
I don't remember the question, but
Question about simplification.
yes, sir.
And what is the term? Which question? Which simplification? Yes, which simplification? Any terms basically you remember so we can identify the question easily.
There were five terms, I think.
Five terms. The last one?
No, the above one.
Four terms. This four terms. This one
This one, AC bar plus B bar C.
plus AB.
Yes, sir.
AC bar plus B plus B bar C. Is B plus B bar C plus AB. Yeah. So can I take these two? So it becomes a B as a common. So 1 plus A becomes 1 plus B bar C plus AC bar. Now, if in these two terms, so I just use a plus BC formula. So it becomes a plus B into A plus C. Okay, so AC bar as it is plus if I use the B plus B bar C, so it becomes the AC bar as it is B plus B bar and B plus C. Okay, so B plus B bar is 1. So it becomes AC bar plus B plus C. Now I use this for this concept. Okay, for these two. So it becomes a C plus AC bar plus B. Again apply the formula. So C plus A, C plus C bar plus B. So this again 1. So it becomes A plus B plus
Sir, could you solve it with K-map method?
C. Okay, we can solve with the K-map method also. A B C 0 0 0 1 1 1 0 0 1. Okay, so it is a AC bar. Okay, so A is 1 and C is 0. But what about B? B value will be considered as a B is 0 and B is 1. So A is 1 this one and C is 0. C is 0 in this one and in this one. Okay, so mark for both. Okay, now second term is the B. So that means B is 1. Where the B is 1? B is 1 in this one and this one. So we consider all four conditions. Now the B bar C. Okay, so that means B is 0, C is 1. So B is 0, C is 1. Consider both conditions. And last is the AB. A is 1, A is 1, This one and B is 1. So B is 1 in these two places, 1 and 1. Okay, so we are considered these two. Clear? So
Yes,
these
sir.
are the representation. Now, one group is this one group is this one, okay, and one group is this one. Okay, so if I am taking the downward group, this one, so answer is A. Okay, if I am taking the this group, so value of A is changes, value of B is changes, 0 and 1. C is constant, so A plus C. And if I'm taking the last one, so the value of A is changes, okay, but the value of B is constant and that is a 1. So A plus C plus B.
Yes, sir. Okay. I have taken only two terms with in common in downward group.
Okay.
That's why I'm getting.
Uh, any doubt? Other doubts?
Sir, I have one doubt in the video lecture of Big Six, sir. That is
Okay.
tri-state inverter, sir.
Okay.
Sir, I
Mm,
didn't get how professor connected resistor, capacitor, and
mm,
something to make that
tri-state.
tri-state inverter, yes, sir, and reduce that number of input of OR gate to the with the tri-state inverter, sir.
Okay. Mm, so, mm, so basically, what is the basically meaning of the tri-state inverter? First thing is this one.
Means, sir, that inverter had three states, either
Yeah.
0, 1, and that impedance part.
Yeah. So basically, if we say that this is my inverter, okay. If I say I apply the 0, I am getting 1. If I say I apply the 1, that is 0. Okay. But one more state is there that is controlled by this. Okay, that is controlled by this parameter, this particular term. Okay, and we can say that this particularly is a either the select line, or basically we can say that it is a high impedance line. Okay, so we use this particular line for providing the third state. Okay, we call them as enable line. So when we can say that we can apply the enable, the input and the output, input and output. If enable line is 0, okay, so that means any input you apply, either you apply the 0 or either you apply the 1, always you are getting the high impedance state. What is the meaning of high impedance state? We are not getting anything as a output. Okay, and if we are not getting anything as a output, we are saying that basically there is some circuit breaking. Like for example, we have this like this one, like this is. So what we are getting at output when enable is 0? Nothing. Okay, because we know that either we get the VIL, we consider as a 0. If I, oh sorry, VOL, we are considering as a 0. If we are getting the VOH, we are considering the 1. But if we are not getting anything here, So what we say, we are assume that my circuit will be breakdown. Okay, my connection
Sir,
will be breakdown.
can sir nothing means 0 volt or
0 volt.
sir that 0 voltage come under BIL part
Yeah, but
means
if we say that there is some particularly variation, like for example, if we have a basically this particular tri-state, okay, so this is designed with the either with the help of transistors. So if my state will be down, we are getting some voltage. Okay, if zero is as a we receive at a output, like for example, if I provide a one and we are getting a zero as a output, okay, so why we define the VOL term? Because due to some resistors, due to some circuit, there is some noise will be there, so the voltage is not exactly zero, it is somehow higher than that one, maybe 0 0.1, 0.2. Okay, that is up to the particular conditions. But if we are getting a zero, either changing the output, we are changing the zero, we are getting a zero, we are getting the one, we are getting the same voltage. So what is the meaning of this one? if
which one,
if we
sir?
are getting, if I am getting apply the zero, we are getting zero. If I apply the one, we are again getting the zero. So what we assume, that there is some circuit that will be break. Okay, if it is a buffer, so in the case of one, it will be provide me one. If it is an inverter, in the case of zero, it will be provide me one. But when we change the input zero and one, we are always getting a zero voltage. So what is the meaning of this one? We are assuming that there is some breakage in the circuit.
Yes, sir.
Okay, and that particularly condition is called the high impedance state.
Sir, my doubt is, sir, if circuit
Yeah,
is break, then the we get that output is a zero, means nothing means 0 volt,
yeah,
potentially zero.
yeah.
Then if we connect another inverter after that in series,
Mhm,
then
mhm.
that inverter treat it is a zero and that trigger that give the output of VOH,
Right,
because
very much.
we are giving them VOL and they give output of the VOL.
Uh-huh. Okay.
Then can we consider it as logic zero, sir? Because in logic input logic zero, we have to input from zero to VIL,
For the
and this
second,
lag
for
between.
the second one, for the second one, it is a logic zero. Okay.
Yes,
But
sir.
for the first one, we can't say that it is a logic zero as the output or logic one as the output. Why? Because we change the input. One we apply the zero, one we apply the one. In the both scenario, we are getting the same voltage, 0 volt. So what is the meaning of this one? For the second, for the cascading part, that is a different thing. But if we are talking about the first particularly inverter, either we apply the zero or either we apply the one, every time we are getting a zero voltage. So what do you understand about this one?
So that output part between the zero means we get output logic zero, means zero to VOL.
If it is the inverter, so in the place of input, when we apply the input zero, we are getting what we are getting. If it is an inverter,
Yes,
okay,
sir.
and we apply the zero, so what we are getting, what we should be getting,
One,
one. But
one, sir.
what we are getting,
Zero.
zero. So what is the meaning of that one?
Mm, yeah.
There is some breakage in the circuit, so that's why we are getting the zero voltage.
Yes, but if we only see the output part and the input part is separate, then
Okay, so
we
why
can.
in that scenario, what we do, we are basically change the input voltage. We apply one times the zero logic and we apply one times as a one logic. In the both scenario, we are getting the same zero voltage. So in that means there is no particular effect of the input on the output part. So that means there is no connection between the input and output.
Okay, sir.
Okay, we can't say
Yes,
with
sir.
the one input, we can't say that it is a high impedance state. If we are getting a zero voltage, so what we do, like for example, if you have a some instrument, basically if you have a torch, okay, you put
Yes,
a
sir.
cell on that one and you just try to on it, it is not working. So you can't say that you are basically you are torch is basically damaged. What you should do, you just change the voltage, you just change the battery. This is the scenario.
Yes, sir.
After you change the battery, you just purchase, you just put in a new cells, that is a higher voltage. Now again the same situation is that your battery, your basically torch will not on. Now after that you can say that you are basically issue in the torch part. The
Yes,
similarly
sir.
thing is that
We
similar
have
thing
to
is
check
that we have,
the
yeah, with for the logic 0 and logic 1 both.
yes, sir, we have to check the inverter whether it is giving the correct output or not. If it is not giving the correct out, we can say that the enable circuit is down.
Yeah, enable circuit is down. Okay,
And sir,
now
after
get,
that, yes, sir, now I got it.
yeah.
That resistor and
So
capacitor parts are
yeah,
connected that.
I just tell you, wait a minute. So we can do that zero, this is the zero, this is the don't care condition. Why? Because any input, the output is same. So we assume that this is the don't care condition. Okay, now if we provide the enable is 1, input is 0, output is 1, enable is 1, input is 1, output is 0. Okay, so now what they do is that we can design a inverter with the help of one resistor and capacitor. Okay, there is one resistor. Okay, and we are using one capacitor. Now initially the capacitor is charged by 5 volt. Okay, and if we are we say that the initial capacitor is charged with the 5 volt, so the what is the output at the across the inverter capacitor is logic 1. Okay, but if no battery is connected with this particularly circuit, so after some time this capacitor start discharging across the resistor. Okay, capacitor is completely discharged across the resistor to the ground. So after that 5 volt will be converted to the 0 volt. Now we are getting a logic 0. Okay, now we are getting a logic 0. Okay, now what we do, if we implement again this logic 0 with the logic 1, so what we do, we are using one capacitor, we are using a
Sure.
5 volt supply, yeah,
So
and we
this
are
part is
implementing,
where we giving the input to the in high input to the inverter and we are getting the output as a logic 0.
yeah, yeah,
This that
that
part.
is, yeah.
Okay, sir.
Okay, now the second thing is that we are apply the 5 volt, we connect 5 volt with resistor and with capacitor. Now we are using that our capacitor is completely discharged 0 volt, so the what is the voltage across this capacitor? 0 volt. Now due to this 5 volt, when the current will be passing through this one, capacitor will be charged and capacitor will charge with maximum applied voltage, maximum applied voltage. And what is this maximum applied voltage? That is 5 volt. Okay,
Yes, sir.
now what they do, if we implement this circuit in a way like if I connect combine these two circuits, so I am using the 5 volt, one resistor, along with the one resistor we are getting a one resistor here, we are using one resistor and one capacitor. Okay, now this is a 5 volt. Okay, so if I give a high logic, if I provide a high logic, so that means if my input is 5 volt, okay, so basically the current will be passing when the capacitor is discharged. Capacitor is discharged, okay, and we are getting a 0 volt across the capacitor. Now the capacitor will start charging by 5 volt. So 0 to 5 volt it will be charged. If I remove input, remove this 5 volt. So the capacitor who charge with the 5 volt, it will be start discharge method. Okay. So who is the enable signal? This is the enable signal. This one is the enable signal.
Sir, I didn't get this part, sir. Could you please
Okay.
explain again?
Yeah. So basically, if I say that I am not connected in a 5 volt, okay, initially my capacitor is discharged. Capacitor is discharged. I am not connected 5 volt supply. Connected 5 volt supply. So what is the scenario is that no current. Okay, because this is a 0 volt, this is 0 volt. So if there is no voltage source, so what is the meaning of this one? No current will be flow.
Yes, sir.
Yes, sir.
Okay, and if no current will be flow, what we are assuming that resistance will be infinite. So only the one situation where there is no current flow, the
Yes, sir.
resistance value is infinite. So this particularly condition is called the high impedance state.
Yes, sir. Then suppose we connected that enable circuit and given that 5 volt.
Yeah, we apply the 5 volts, so our, automatically my circuit will be start working. And if we are getting a 5 volt as an input, we are getting a 0 as an output. If we are getting a 0 as an input, we are getting a 5 volt as an output, or basically logic 0 and logic 1. I'm not saying 0
Means
and 5.
means first we have to give the 5 volt input. Then we
Yeah,
have to give the,
yeah,
because if we give first 0 volt, then we get 0 because that time capacitor is not charged.
mm,
First we have to charge that capacitor. Am I right, sir?
yeah. We have to charge the capacitor.
Then every time we use an inverter, then we have to first charge that capacitor.
Mm, exactly.
Okay, sir.
Mm,
Sir, then in second part, sir, where the resistance you giving the 5 voltage input,
mhm.
then you get also 5 voltage output, sir, because at that time the capacitor is charged with the 5 volt and giving the high voltage output.
Mm, if you are saying that, like for example, for the second part, this one, you are saying this one.
Yes, sir. Yes, sir.
Initially, if the capacitor is 0 volt, so the current will be start flowing. Okay. If the capacitor is
Yes, sir.
5 volt, capacitor voltage is 5 volt. So now what is the current
Zero potential difference than
potential?
capacitor
So
will be.
yeah, because the same potential, 5 volt and 5 volt. If the same potential, no current will be flowing. So what we assume that resistor will be the infinite or high impedance resistor we are using.
Then in output we get high because the capacitor is charged with the 5 volt.
That is dependent on at what point we are getting the output. If we are getting the if we are taking the output across the resistor, because across the resistor we are getting a 0 voltage drop, so we are getting a 0. If we are taking the volt output voltage across the capacitor, we are getting a 5 volt.
So because in first part we are getting the output from the capacitor part.
Yeah,
And suppose that this is the same inverter, then we also get this part as a output from the capacitor part.
I am just telling you that we can take the output from this one. Okay. uh, if suppose for example I am getting the output from the resistor, so what is the scenario?
Scenario will change it, sir.
Scenario will change. So according to I just use basically where we are getting the output. That is, I just take that I can take the across the capacitor, across the resistor. So according to this one, my logic will be changed. Okay. I
Sir,
think the
this is a,
professor is not taking any basically any particularly component for the output part. I think so. The
yes,
professor will not taking any output across any particularly component. That is only for the understanding that we can take the voltage across the capacitor. We are getting this one. If we are getting the voltage across the resistor, we are getting this one. Okay.
So what is low resistive part?
Low resistive part. Basically, the
Yes, sir.
low resistive part is that when I say, like for example, this one, second circuit I am taking. Okay, this one. Now, if I apply the 5 volt, okay, and we assume that the 5 volt completely applied across the capacitor. So, what is the meaning of this one? Is that the voltage drop across the resistor is very less.
Yes,
Okay.
sir.
If 5 volt we apply and all 5 volt will be appear across capacitor, so that means the voltage drop across the resistor is very less. So what is the voltage drop across the resistor? VR is equal to nothing but IR. So if R value will be less, the voltage drop is very less.
Sir, please explain one more time.
Hmm?
I didn't get it.
Like for example, we have a I am using this one 5 volt. Okay, I am using one resistor. Okay, and I just say that I am getting the 5 volt across this one. So what is the voltage drop across this one? Less than 0.1 volt. Because if I apply the 5 volt and all 5 volt will be appear across this resistor, so the voltage drop across the upper one is very less.
Yes, sir.
Okay, and what is the voltage drop is V is equal to IR.
Yes.
Okay, now the voltage drop is less, that means the value of resistance is very less. Okay,
Yes, sir.
so it is called the
Low resistive.
yeah.
sir, it means this diagram is a inner working of that inverter part, capacitor and
Mm,
resistor.
you can design with the help of transistor also. Inverter internal diagram with the transistor also. And don't know you are aware with the transistor working.
Yes, a little bit, sir.
Okay, a little bit. If I say that if I design my circuit in this way, like there is one resistor, 5 volt I provide here, one resistor, we are getting an output. Okay, now there is one transistor, it will be grounded, and we are taking that as an input. Okay, so when input is 0, so this transistor is off.
Yes, sir.
Okay, so that means this 5 volt will be passed through this resistor and we will be getting at the output. So what is the output?
5 volt.
Almost 5 volt minus the voltage drop across resistor.
Yes, sir.
Okay, And if we are getting the input as a 1, so the transistor is on, the current will pass from this circuit to this one. The voltage drop across this point is, what is the voltage, output voltage? The output voltage is between these two terminal voltage, and this is completely zero, almost zero, not completely zero, almost zero. Okay.
Okay, sir. So it
So
means transistor is on means behaving like a conductor now.
yeah, transistor will be in conducting mode.
Yes, sir. Also, this part is a more clear, sir. But that design I didn't get too much.
Okay. So basically that is only for the high impedance state, and what is the low and what is the high level. So that is only for that one. Okay. So I think that's clear.
Yes, sir.
So thank you all.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Yeah. And if you have any basically deadline issues, so just directly mail to the support team and mention that due to the quiz exam, we are not completing that one. So kindly extend the date for 3 days.
Sir, where can I get that PDF of quiz one?
PDF. Uh, okay. Let me discuss with the professor, and after that we will provide you.
Okay, sir.
It will be provided. Yeah.